Okay, so last week we dived into naming and formula writing for covalent compounds, and we had you guys practicing how to recognize if something was going to be ionic or covalent, and we recognized that it was the existence of a metal in the formula made it ionic, and if there were no metals, then it was covalent. So this week we're going to focus on those ionic compounds, and to be able to do that, we are going to need the charges on our periodic table. And then we're going to switch over to the next page in your packet and go through the rules for naming ionic compounds and writing the formulas. We'll do a little bit of practice, and then I will tell you how I intend to wrap up term 3 and step into term 4. So first off, you should have these on your periodic table because I have mentioned so many times to get them done. However, if you do not, we need to write down the charges on your periodic table. You cannot write ionic formulas if you do not have the charges. So again, starting all the way over in the left above hydrogen, these are all a positive 1. Above beryllium, these are all a positive 2. We are not doing any of the transition metals in this class, so we're going to leave those blank. Above boron, so you'll see boron, aluminum, gallium, these are all going to be +3. The next column we don't normally see in ionic compounds, although you may see some of these lower ones. And if you see like tin or lead, you can assume that those are a +4. We know that it's 4 because it's in 14, and we know it's a plus because it's on the left side of this stair-step line here. Then we're switching over to above nitrogen. This is where we switch to negative. So -3 above oxygen, a -2 above fluorine, a -1. And above helium here, again, these are the noble gases. These are going to be 0 because they do not form bonds. They don't gain or lose electrons, so they do not have a charge. So make sure you have those written on your periodic table. If you need to, you can always go back and watch the video or press pause on that and get it written down. Okay, so like I said, we are working in your packet. It's the same packet that we've been working in. We are almost to the end, and we're going to fill out this page of notes today. So if you don't have this page, you're going to need some notebook paper, and you can periodically take pictures as we go through. But let me switch over to my iPad now. Okay, so if we're talking about ionic compounds, what we said is ionic compounds are always going to start with a metal, and those metals are that left side of the stair-step line, and then they're going to be followed by a non-metal. But I do want to introduce that there is yet another thing that you can have. So you can have a metal, and you can have a thing called a polyatomic ion. And polyatomic, poly is a prefix meaning many, so it's many atoms, right? And I'll show you what those look like when we get to those. So if you need to write the name for an ionic compound, this is really easy because we don't change hardly anything at all. So you're going to write the complete name of the metal unchanged. So you're just going to write sodium, calcium, aluminum, copper, iron, like whatever the name of the metal is, you just write its name. You don't do anything to it. And then we're going to write the name of the non-metal. But just like with the second element in our covalent compounds, we're going to change the ending to IDE. So oxygen to oxide, fluorine to fluoride, sulfur to sulfide. And you should have written all of those down on the previous page of notes. If you didn't, I would go back and watch last week's video to make sure you have those so you get the endings correct. Now, if the anion is made of more than one nonmetal, all right, the key here is the more than one. then you're going to write the name of the polyatomic, but you do not change the ending. And we are never, ever, ever going to use prefixes with ionic compounds. So let's talk about polyatomic ions for a second. There's like literally hundreds of polyatomic ions. We are just going to focus on 4 so you get the idea of what they are. So many atoms here. So all of these things are more than one element. And for us, they're going to be more than one nonmetal. And so for us, ours are all going to be some nonmetal plus oxygen. Right? So for us, our second nonmetal, the mini here is going to be oxygen. And they all have their own distinct formulas. So you need to recognize that nitrate means that you have nitrogen plus some oxygen. And that whole collection of 1 nitrogen and 3 oxygens has a charge of -1. Sulfate is again sulfur plus some oxygen, and that entire collection of 1 sulfur and 4 oxygens has a charge of -2. Phosphate is phosphorus plus a collection of oxygen, and that phosphorus and 4 oxygen all together have a charge of -3. So there's a whole set of rules about how many oxygens you put with there and what that does to the name and all that sort of stuff. And that is beyond the level of what we need for this class. So all you need to know is nitrate is NO3 with a 1-. Sulfate is a SO4 with a -2. Phosphate is a PO4 with a -3. And then we have this other one, hydroxide. Well, hydroxide still ends in IDE, but it doesn't sound like any one element. It actually sounds like 2 elements, because it is. H for the hydro and O for the oxide, and that is the formula for hydroxide, except we flip it. So it's OH, and that collection of OH has a charge of -1. So if you recognize an NO3, a PO4, an OH, a SO4, you use this name, okay? Not nitride, sulfide, phosphide, something like that. So you should notice that these are all at least 2 capital letters here, which helps make it easier to spot when you have a polyatomic ion. So let's look down at these examples. Again, we are just writing the names of these things. So the first one, Na, the name of that is sodium, because Latin. And Cl is chlorine, but I change my chlorine to chloride, and that's its name, sodium chloride. It's table salt. That's all there is. That's all you have to do. So the next one, Al, is aluminum, although the rest of the world calls it aluminium because metals should end in IUM, but aluminum. And then the O, the oxygen, becomes oxide. Now do notice that I don't care about this number 2 and that number 3 in my name. It has nothing to do with the name. When I'm talking about ionic compounds, the numbers don't matter. They do with covalent, but not with ionic. Okay, the next one, Ba, barium. But then I recognize here I've got 1, 2, 3 capital letters, not 2, 3. And if I see those 3 capital letters, that should tell me I need to look up here and say, well, what is that thing? Well, it's sulfur plus oxygen, which is sulfate. Again, the 8 implies plus oxygen. So that next one, the K, again, stupid Latin, it gives me potassium. And then the PO4, again, that is 1, to 3 capital letters, which is telling me I need to look up there at that chart, and I've got not potassium, I've got phosphorus plus oxygen, so that is phosphate, because again, the ATE is telling me it's plus oxygen. Okay, so make sure that you have the correct ATE ending on those. Okay, so that's the easy part. Make sure we can still see our polyatomics. Writing the formulas is where it gets a little on the tricky side, okay? So follow along. So if I have the name and I need to write the formulas, well, I need my symbols. So I'm gonna write the symbol, and that means the Ca, the F, the N, the O. All right, the symbol for the cation, and again, the cation just means the metal, on the left with its charge. That's why we wrote the charges on the periodic table, so you can do that step. And then I need to write the symbol for the anion on the right with its charge. And note here that the anion can be either a nonmetal or a polyatomic. Okay. Okay. So the whole point of an ionic formula is having the charges balance out, all right, or cancel out. The easiest way to do that is to cross the numbers in the charges, but not the plus or the minus sign, so that the number on the charge becomes the opposite subscript. And when we are writing formulas, we don't write the number 1, so we're going to continue not to write the number 1. And what that means for a polyatomic ion is if you have to put another subscript on a polyatomic ion, that's why I wrote parentheses around them up at the top. I think that's how you spell that. Because the safest thing to do is to always have your polyatomic ion in parentheses, and then you never have to worry about it. But you are not going to change the subscript that is on that oxygen in the polyatomic ion, because that will change what polyatomic ion it is, and we don't do that. So if there is a lowest common multiple, then we're going to reduce our numbers down. What that is going to look like for us is if you have a +2 and a -2, you know that switches, that is a 1-to-1 ratio. If you have a +3 and a -3, that is also a 1-to-1 ratio. So if you have the same charges, you end up not putting any numbers because they cancel each other out. They both have a lowest common multiple and reduce down to 1-to-1. So let's do some examples here. So calcium fluoride. So I'm going to write the symbol for the cation, which is my metal, on the left with its charge. So if I look up on my periodic table, we said calcium was a +2. So I'm going to write Ca and a +2. Fluoride is the element fluorine. And on my periodic table, fluorine was a -1. So I am going to take the number and cross the numbers, but I am not going to take the plus or the minus with me. And I'm going to write Ca, and I would write a 1, except I said I don't have to write the number 1. So I'm going to take that off. All right. And then I'm going to write the F, and I'm going to take the charge from calcium and write that number, 2. So no plus, no minus, no number 1. So what that is telling me is that for every single calcium, I need 2 fluorines to make it cancel out. So 1 calcium, 2 fluorines, +2, and 2 of the -1s, and those cancel out, and that's my formula. Now, I had you do this before with the dots and the arrows and right, and we did this and we did that, and that's where these formulas come from, but it's kind of a pain to have to do that every single time you have to write an ionic formula. It's much easier to conceptualize this crossing of charges, and it gets you the same result. So lithium nitride. Lithium is a Li. It has a charge of a +1. Nitride is the element nitrogen. It has a -3. And so when I take this number 1 and cross it down, and I take this number 3 and cross it down, I still write Li. Nitrogen's 3. I write N. And lithium's 1, except I don't have to write the number 1. All right, and what that was telling me is that it requires 3 lithiums to balance out with a single nitrogen, right? And that these guys gave a 1, a 2, and a 3 to be able to make that happen. So that's how I know those are the same thing. Doing all of this is a lot more time and space than simply crossing the charges. Crossing the charges will always work. Okay, moving over to the other side, magnesium hydroxide. So magnesium is a charge of +2, so Mg +2. Hydroxide. Hydroxide. Where do I know that? Well, it sounds like a hydrogen and an oxygen because it is, right? It is up here. All right, it's this guy. And so it had a -1 charge. And then I need to cross that 2 over to here, cross my 1 over to here, and I would write Mg, the 1, except I don't have to write 1s. And I'm going to put my parentheses on my hydroxide, because if I always do that, I will never make a mistake. And then magnesium's 2 goes on the outside. So this says that for every 1 magnesium, I require 2 hydroxides to cancel it out, right? So I would have a Mg and a +2, and I would have an OH and -1 and an OH and a -1, and I notice that +2 and those 2 -1s, those balance. Okay, aluminum sulfate. This one's gonna have so many numbers because everybody's got numbers and charges. So aluminum is a +3, all right, so Al +3. Sulfate, that's telling me I am sulfur plus an oxygen. Don't guess, look it up here. It's SO4 in parentheses with the -2 charge. I'm gonna cross the numbers again, so that goes out there, 2 goes down there, and that formula is Al, and it takes the 2 from sulfate. I'm going to do my parentheses around my sulfate, SO4, write the whole thing as I've written it in the box, and then it takes aluminum's 3. So that's telling me that I have 2 Al plus 3s that cancels out with 3 of the sulfates. And you should see that those charges balance. 2 plus 3s is a +6. 3 minus 2 is a -6. +6, -6, they cancel out. So take a picture really fast if you need to. All right, so scrolling up for the practice. The first thing I want to do is actually write down all of the charges. So it says specifically, write the charge on the metal and the non-metal. Then you'll cross the charges to write the formula, and then you'll write the names, right, with "ide" at the end here. So we'll do all of the charges, and then I'll do a couple of examples, and then I'll give you time, and I'll fill in the actual answers. So let's do all the metals. The metals are my cations, they're on the left. My non-metals are my anions, they're on the right. So sodium +1, Magnesium, +2. Cesium all the way down there is also a +1. Strontium is a +2 right below it. Barium is a +2. There's that cesium again. Lithium again. Aluminum again. Ga, that's gallium. I'm not sure we've used gallium, but if you look, it's directly below aluminum. It's +3. Potassium is a +1. Be, it's beryllium. It's actually up at the top. It's +2. Calcium is a +2. So my nonmetals, there's not very many of those, right? These are all in that far small little collection on the right. We've reused some of these. So nitrogen is -3, chlorine is -1, bromine right below it's -1, oxygen's a -2, sulfur right below it's a -2. P, that's phosphorus, not potassium. Phosphorus is directly below nitrogen, so it's a -3. This SO4, I'm going to go ahead and put it in parentheses like I've written it up at the top. And in that box of polyatomics, it's listed as a -2. This is iodine. Let me go ahead and draw its crossbars. It's below bromine, so it's a -1. Fluorine's a -1. There's my chlorine again and my sulfur again. This OH, I see 2 capital letters, so that's one of those polyatomics. Put it in parentheses, and its charge is a -1. So I am going to do these 2 that I've already marked. Okay, so I'm going to cross just the charge again. So I do the Na, I take the 3 from the nitrogen, and then I write the N, and I take the 1 from the sodium, except I don't have to write it, so it's just Na3N. The name of that, Na, because of Latin, is sodium. And the N, nitrogen, becomes nitride. Skipping down to this next one, I've got a 2 and a 2. So if I cross those, it would be SR2O2. However, this is when that lowest common multiple thing applies. +2 and -2 is really a ratio of 1 to 1. So I can rewrite this as SRO because the +2 and the -2 cancel out. Okay, so they have the same charge. If they have the same charge, you don't have to write the numbers because they cancel out. SR is strontium. And oxide. Okay, so I'll give you a couple of minutes. I'll start writing the answers in so that you can look up at the screen and check yourself as you go. For a couple of these, I want you to note between the BAS, All right, that is just the element sulfur. So we have the sulfide. But for this Li2SO4, that is sulfur plus oxygen, so it is sulfate. Do not switch those up. Only add the ATE if there is oxygen in that polyatomic ion. Okay, so there's the answers for that whole section. So if you finished, you can go ahead and check your answers really fast. If you didn't, just go ahead and take a picture so you can use it to check your answers later, because I do want to switch back over and talk to you about how we're going to wrap up term 3 and move into term 4. So quickly, take a picture. All right, moving back. Okay, so what is due? Well, what's not due is office hours this week, because Friday is records day for us to enter grades. So we're not supposed to have classes, no office hours, anything like that. So you can't meet with me on Friday, but if you need to meet with me, you know, I still got my office hours on Thursday for you guys. So I opened up a new video yesterday, video 31, which is like a combined review of all this naming and formula stuff. That's due Monday night like normal. And then a new CALM assignment also opened up yesterday. That is also due Monday, topic 8, section 4. That is going to count in your assessment category, also due Monday. So those two things, based on this week's work, are both counting for term 4, not term 3. The last things that counted for me for term 3 was Ed Puzzle number 30 and the CALM topic 8 section 3. Those are both due this past Monday. And I gotta say, if you didn't do those, that CALM grade boosted people's grades. So you can still finish stuff for me for term 3 up through Friday, and I'll get those incorporated into the term 3 grades. But moving into term 4, we're going to shift class onto Google Classroom, because if you'll notice, we are at the end of the packet, the piece of paper that I have you, or that I gave to you. So since we don't really have any paper stuff left, the easiest way to get materials to you is through Google Classroom. So that's how I will shift and give materials to you. I will still communicate with you through email and remind, but I'm going to give you materials through Google Classroom. So that login code was on the weekly plan, and it was in the email that I sent out this past weekend. So go check into that. Finally, for those of you who are going to watch this later on video, you have to communicate with me so I can give you class credit, because otherwise I don't know that you're watching these things. If you have questions either over specific assignments or this assignment in general, I've got office hours on Thursday, tomorrow, that you can pop in, and otherwise that's it. So again, you can still do stuff from February and March. It's listed as MI or missing in your term 3 grade right now, and is actively bringing your grade down. The newer material from the second part of March and in April, if you didn't do some of that stuff, then it is missed opportunities to bring your grade up. So sitting where grades are, I know we've got a fair amount of like B's on the cusp of a B plus, or B plus on the cusp of an A minus. So there might still be things that you can do to pull your grade up. So please go and look. And then I'm going to stop recording. And if people have any questions, you can hang out and ask me.